Hey everyone, so today I wanted to give a New Year's problem for all of you. So the problem is going to be the sum from 0 to infinity of 2 times the ln of 45 to the n over n factorial, and subtract a 1 for luck, I guess. So while this problem may seem daunting at first, I think a way to solve it is actually to take a step back and consider potentially a harder problem. Let's define a function. Let's call it f of x equals the sum from n equals 0 to infinity of x to the n over n factorial. So this is somewhat of a harder function, right? Because, the one we have here is just a specific example. This is f of 2 ln 45, right? So let's see what we can do with this. Let's remember that we can use calculus to do this kind of problem. And why don't we just take the derivative and see what we get? Well, when we try to find f prime of x, we get the sum once again. And what we see is this x to the n, well, the derivative of x to the n is n times x to the n minus 1. That's just the power rule. And remember, we can use that since n is kind of a constant here and x is our variable. So what we get is n times x to the n minus 1 over n factorial. And you see how we used to have it from 0 to infinity? Well, we wouldn't really need to take 0 because it's just going to cancel out here. So we're actually going to take this from n equals 1 to infinity. If we plugged in 0, we would get 0 in the expression. But what we can do here is we can actually just cancel out these n factorials, because remember, n factorial is equal to 1 times 2 times 3 all the way times n, right? So if you have that, n over n factorial, these n's cancel out, and you're left with n minus 1 factorial. So we get that this is the sum from n equals 1 to infinity of x to the n minus 1 over n minus 1 factorial. Okay? So this doesn't seem like it's helped us that much, but why don't we just try to write out what these two expressions are? F of x, if we just write out a couple terms, we take n equals 0, we're just going to get 1 over 1. N equals 1, we're going to get x over 1 factorial. Then n equals 2, we get x squared over 2 factorial. And you can see the pattern, x cubed over 3 factorial, etc. Now let's look at f prime of x. If we take n equals 1, well, we're once again going to get x to the 0, which is just 1, over 0 factorial, which is equal to 1. If we take n equals 2, we're going to get x to the 2 minus 1, which is 1, x over 2 minus 1 factorial, which is 1 factorial. In fact, you'll see that we're actually going to get the exact same thing if we just continue our pattern. What we're observing here is that f of x equals f prime of x. If we take the derivative of our sum, our infinite sum per se, it's the same as the regular function. And there's only one other kind of function where we've seen this happen. In fact, it's the solution to dy dx, or f prime of x, equals y. Using separable differential equations, we can solve that y equals e to the x. In general, we've basically proven that f of x equals e to the x. So, now that we know this to be true, we can finally go back to our original problem. So, let's look back. We are trying to find f of 2 times ln 45 minus 1. Okay? Well, using this identity up here, we get that this is e to the 2 ln 45 minus 1. And if you would like to, you could finish here, but there's a couple simplifications we can do. This here is e to the ln 45 squared using simple power rules, minus 1. But hopefully you should remember that the exponential and the logarithm are inverses. So this is simply 45 squared minus 1. And finally, you can use your calculator, or maybe you already know it. 45 squared is equal to 2025. Minus 1 is equal to 2024. So hopefully that problem was interesting to you and introduces the idea of power series, which hopefully I will do a video on later on. Okay, thank you.